rest of this chapter, kind of after all that, deals with what are called quadrilaterals. I think it's quadrilateral. Is that not? Whatever. Quadrilaterals. Quadrilaterals are going to be four-sided polygons. That's really all it is. Okay. You've got what are just four-sided polygons. I don't know. Sometimes that's sketchy. So you have four-sided polygons, and what happens then is that you get them branched off into what we call like a family tree. And I know you guys have all seen all the different shapes and all that. You've looked at them at some point in time. You've learned a little bit about the different properties and whatnot. One of the things that we talk about is that when you have four sides, it doesn't have to be, oh, this was awful. Let's see if I can draw something. It doesn't necessarily have to make a known shape. It just has four sides. Okay. If it has four sides, what do all the angles have to add up to equal? 360. Will that ever change? No. That'll never change with four sides. Okay. Now, when you get into it, you're either going to have what's called a non-parallelogram. Oh, I abbreviate the word parallel with /E-ogram. Is that okay? Parallel lines. Versus the parallelogram. Now, when we get into parallelograms, that's when we start talking about parallelograms, rectangles, rhombuses, squares, things like that. Non-parallelograms, we'll talk about. They can look like this, or they can be trapezoids. They can be kites, and so on. So there's things we will look at, but we always start with parallelograms. And if I'm not mistaken, you probably already know a lot of the different properties of them from a class at some point in time in your lives. For example, what is one thing you could tell me about a parallelogram? Exactly. Hence the word parallel. All right? So when you have parallelograms, you always have two sets of parallel sides. The way we say that is that we say that opposite sides are parallel. So we'll make a list here. Properties of parallelograms. Oh, let's just say this. Both sides or opposite sides are parallel. Oh, pretty obvious there. Do you remember something else? Well, actually, let's do this. Let's go off the idea of being parallel. When you have parallel lines, cut by a transversal. If I do this here, if these are parallel, then this angle and this angle are on the same side on the inside, which means those two are what? They're supplementary. Okay? Now, if you turn your head sideways, isn't this line parallel to this line? So if this angle, well, let's just throw a number at it. Let's say this angle is 100. What would this angle have to be? 80. Okay? Which means this angle here has to be 80. Which means this angle here has to be, I don't know, I'm standing here, right? So that bottom right one has to be 100. Okay? Now, what I'm showing here is that angles that are next to each other, remember we always say consecutive? Consecutive angles are always supplementary. No matter where you're at. If I'm here, then the next angle to my right is my supplement. If I'm here, the next angle to my left is my supplement. It always works. So we know that opposite sides are parallel. Consecutive angles are always supplementary. I'll write in here at 180 in case you forgot. Look at the angles that are opposite each other. When I say angles that are opposite each other, what do they look like? Not alternate interior, but because there's no transversals there, but are they the equal? Angles opposite each other are always going to be equal. And they add to 180. Consecutive angles are supplementary, they add to 180. And I'll make another listed on the smartboard here too, so we have that. So we have opposite angles. Are congruent. Oops. Good morning. How are you? I'm fantastic. Okay. What else do you remember? Oh yeah. What's that? Oh yeah, that's a quadrilateral. What do you know about the sides? They're parallel, but what else are they? No. Their opposite sides are also congruent. So opposite sides are parallel and they're congruent. So the opposite sides parallel, opposite sides congruent. Okay. Really the last one that we get into for right now. You know what that's called? When I go vertex to vertex, what those are called? In quadrilaterals and stuff, they're going to call those diagonals. They're going to call those diagonals. And what they do inside of parallelograms is that they bisect each other. Diagonals will always bisect each other. So this chunk is equal to this chunk. This chunk is equal to that. So the other part here for now is that diagonals bisect. List. That's kind of where we're at. And again, it just winds up working through, we're going to have pretty quick algebra problems, pretty quick working with the angle problems. There's not a lot of craziness with this stuff. You don't have to do any proofs, you don't have to worry about any of that. But it's just a matter of using the properties to solve problems. Right? Then we'll get to slopes and all that kind of stuff later on in school. You guys vaguely remember most of those, I'm assuming? At some point in time, I know you've seen like at least those three, I would imagine. All right, let's do some problems. We'll go one by one here. So let's see here. These are all given to you to be parallelograms. So if A is 64, what would B have to be? 116, yeah, it's got to be a supplement because it's next to it. It's not across from it. Remember, that's the difference here. That's the difference. We're looking at Can you identify if it's an opposite angle or is it a next to angle? B is a next to angle. So it's just a supplement. Sorry. So it's a supplement. So like you said, it'd be 116. Not bad. What's G? Yeah. Pretty easy, isn't it? It's just identifying, are you an opposite angle or are you a next to angle? Remember, consecutive means next to. The next angle over. Right? It doesn't have to be opposite. If opposite, and let me ask you this, what kind of a parallelogram do you think you would have if you had consecutive angles congruent? Or rectangle? I'll ask you this. Is a rectangle a square or is a square a rectangle? Ah, but a square is a rectangle. But a rectangle isn't a square.
Oh, wait. Wait, what?
Yeah.
Wait, okay.
We'll get to it. We'll get to it.
Say that one more time.
One more time.
Yeah.
One more time. We'll get to it. A square is more specific than a rectangle. Yeah. A rectangle, or a square is a rectangle because it has all the properties of a rectangle. But a rectangle isn't a square because it doesn't have the properties of a square. Bless you. All right. If this is a parallelogram, how do I solve for x and y? Solve for x and y. Like I said, a lot of this stuff is going to be relatively straightforward. Again, it's not that the math is going to be tough, it's just remembering what some of the properties are.
Kind of nice to see quick output from things.
We are. You weren't around yesterday. Tomorrow I won't be here because I will be here, but I won't be here. We're going to be rewriting and redoing the entire final packet stuff for geometry tomorrow, as they give us a release date to do all that. So I don't know specifically what the proof would look like on the final. I don't know if we're going to have one that's going to be by hand or if it's going to be a multiple choice like we've done in the past. After tomorrow, I'll be able to tell you on Thursday. Because then we're going to work on the review packet and have all that stuff ready to go. But for intents of like making a proof and doing it, we're done. Except for what step would this be, that kind of stuff.
So are we going to do
Okay. So did you guys get 2 for x and 77 for y? I was joking. See if you're paying attention. All right. Now, when you get into the diagonals, that's where things start to get a little messy because it's tough to see what part goes to where. One of the things that I would suggest when you're looking at these, it's what I would suggest, whenever you see a parallelogram that it gives you stuff with diagonals, look for the parts that are on the same side of the diagonal. Does that make sense? Like it's above the diagonal there on that side, and the other one has it above and above here. That's how you would set those up so you know which ones correspond to which. So if diagonals bisect each other, what do they do algebraically? What does that mean? They split in half, so that means they have to be equal to each other. Okay? So when you set those things together, we know that we're going to have, and like you were saying, we have 2n minus 1 is 9, and 3m has to equal n plus 8. It's nice to see quick math. Josh, you just said what m was. What was it again? 4. Subtract that, you get 2. Divide that out, you get 4. And what'd you get for n then? Again, it's not that the math is going to be difficult. It's just remembering how to set it up. And that's kind of what we're getting at here. So this is kind of a nice little section here. When they label parallelograms, they usually put that symbol. Parallelogram WXYZ. That means what two angles are congruent to each other? If it's parallelogram WXYZ, just looking at the lettering, what sets of angles are congruent? W and Y, and X and Z. Just because it goes 1, 2, 3, 4, opposite angles would be the same. So what we do is this. We draw it out. Does it matter where you start your letters? Nope. You pick a spot and you go in order, just like you do with triangles. It does not matter. Then you read it. It says angle W is 50 degrees more than angle X. What does the word is mean in math? Equal. So it says this. Angle W is 50 more. What does 50 more mean? Plus 50 to what angle? X. So angle W is 50 more than angle X. All right? Sketch it and figure it out. Well, if W is X plus 50, what's angle X? X. Exactly. What do these two angles have to add up to equal? Right. So what's X plus 50 plus X? Right. What we're doing here is we know that angle W plus angle X has to add up to equal 180 because they're next to each other. They're consecutive. Right? So they're supplementary, which means they add to 180. Well, angle W, I don't know what it is, but I know that it's 50 more than X. So if I subtract 50 from 180, where you just said it, what was it? No, it's only 9 o'clock. Sorry. I had a 10 over 8 joke earlier, too, because it couldn't get away from the buffet. So what's X? 65. So now you have angle X is 65, which means if this is 65, what's W? There you go. It's the idea that you can take, you can take some stuff that was written out in words, create a diagram so you understand where things are placed, and work with it. Right? It's not tough. It's just using some quick substitution tricks. Oh, I know, right? Bless you.